the number one problem you see out there, or that's a hazard, whether it's a small apartment building or a single family home. Can you touch on that?
Yeah, well, the most injuries and the most problems are related to decks. So a lot of people don't know that. And that's because there's a lot of things that can go wrong on a deck, especially the higher up they are.
Sure. Now it's also for the railing.
Railings, steps, stairs, how high they are off the ground. Man, there's a ton of engineering in that, and I'm going to let Tim talk all about that.
Right. And Tim, of course, your background is
engineering, mostly structural. That's what I specialize in, yep.
So when we read about there's a graduation party or some sort of party in a third-story balcony in some apartment building, and 32 people go down 3 flights, that was part of the structural component.
Yeah, that tragedy happens way too often, and I think what really happens there is that decks are viewed as second-class citizens in the building industry, and they're not given the attention really that they should be given. But when you have a deck and you have a party, or there's a view to be had from your house, what's the one place where everybody wants to go? Well, they want to go to the deck.
Right.
Okay, so you've got 20 or 30 people loading that deck with a far higher load than any other part of the house may ever get out there on the deck that might have been an afterthought.
Now, I know, Mark, your background is as a contractor.
Yep, we're an engineering and building contractor.
Okay. I'm sure you see a lot of this where that big beam cantilevers outside the structure.
Well, we see everything, Pat.
Right.
I mean, we see the good, the bad, and the ugly big time.
Right,
So
right.
what typically happens, though, is that we'll go out and find the problem, and then we'll come back and say, I've got a file on my computer called donut construction photos, and I'll send it to copy to Tim, and I say, you aren't going to believe this, buddy. And there's a reason why there's such a high fatality rate or problem rate with decks, is because oftentimes they're built usually by the homeowner's brother-in-law, somebody like that.
Exactly.
And they don't have any clue what they're doing, or if they're a good carpenter, what they don't understand the engineering principles behind it. And that's where the problems come in.
Now, for the regular homeowner that's adding a deck or replacing a deck, you shouldn't just hire a contractor and let him pull his truck up and go to town. Should we speak to the building permit department or an engineer? What's the best course of action?
Well, I think if you just hire the first guy that comes along with a tool belt and a pickup truck and say, hey, build me a deck, you're begging for trouble. We'll let Mark talk about the permitting aspects because he's the one that pulls those building permits. So,
well, number one, going back to the thing, I always say pick somebody who's a 9 out of 10 or a 10 out of 10 at what they do. So if you're going to hire a deck guy, hire a good deck guy, and then they have the system down. And the system is, number one, decks are a permitted structure. A lot of people don't know that. Do I need a permit for my deck? Absolutely. And as soon as it gets above 30 inches above ground, there's a multitude of engineering things that come into play that have to meet minimum building code.
Okay, that's a good point. Is in the real estate industry, I hear it all the time in the field, oh, you don't need a permit for a deck.
Yeah, that's wrong. Almost every single time. Now, there's different levels of permitting. If you are going to remove and replace an existing deck that's low to the ground, that's a no-brainer. It's an over-the-counter permit. It's very inexpensive and it's easy to do. And most homeowners that have some experience in construction could probably do the work on that if they had some help or something like that. It's when you get into the ones that are higher up, there's attachments to the building itself.
Right.
That's where things start getting where you need to have the engineering and stuff like that.
One of the things that we also learned about is for children or pets that in terms of the
picket and railing space.
Picket and railing space, okay.
Yeah, that's 4 inches and then 6 inches where there's a step so that no child can basically slide through and fall through.
I see. Now, part of the problem with decks is they are outside 24/7, right?
yeah.
Could have been originally designed well, and just the weather conditions or termites take care of it and make it.
Yeah, the weather's going to take down anything in time. Sooner or later, the weather is going to win every time with whatever it is. But decks are especially prone because, for example, today we were looking at a house, a very old house, that had decks all the way around it. And of the 4 or 5 decks that were there, all but one of them were just pretty much shot. They were riddled through with rot, and then they were done. They had reached the end of their useful life, which is about 20 years. You can prolong that life if you design and use good materials like pressure-treated wood. These particular decks just use regular lumber.
Right. Now they also have the, I'm not sure the product name, but imitation wood, right? To look like
that's a composite.
Composite.
Yeah. There's a lot of brand names. Trex is the most common one that you hear out there.
Okay.
Yeah, and those typically run about the same price. They're very good durability. We have a lot of demand for those, and so we see a lot. We install a lot of those.
Okay. Now, to do this correctly for the homeowner that's watching, that they want to replace the deck or the stairs going up to the second story deck, we see a lot of that. They could hire a contractor who will hire all the players, including the engineer or designer.
Sure.
Or they can act as a owner contractor.
Owner builder.
Owner builder is a term.
Yep.
Okay. Can you speak to the difference between those?
Yeah, that's a good one. That's a good point too. So number one, and we encourage this too, if you have the time and if you have the knowledge or the time to put in to gain the knowledge, then you can do, on a residence, you can run your own work. You could be your own general contractor. And there's an exemption in the California contract law. There are certain requirements we talked about on our last show that you still can't avoid paying workers' compensation insurance. If you hire subcontractors, they still have to be licensed, etc. But you and any member of your family can work on that project, including decks. However, the code doesn't change if you're an owner builder. You still have to follow it. You're still most likely going to be required to hire either a licensed architect or a licensed engineer to do the design on that deck.
Okay, because a lot of people insist that having a building department involved in their deck is a waste of money and a waste of time.
Yeah, we don't subscribe to that because oftentimes if it goes unpoliced during design and construction, not every time, but most of the time they cut corners. They meaning the builder or the owner builder or the contractor. So we prescribe to doing things the way they're required by law, which is to be designed professionally and then built under a building permit, which then is going to make the local jurisdiction, which is either the county or the city, a third-party inspector and plan checker. And now you have these built-in levels of checking the quality during and after the work.
Sure.
We can almost tell every single time when we go look at a deck, this one was permitted, this one wasn't.
Right.
It's pretty obvious.
Okay. Let's speak about in terms of how the ground plays into these
Huge.
decks.
Yeah.
How do we support?
Well, I'm going to let Tim talk about that because he designs that all the time.
Lots of times decks are built out over a slope, and a lot of times the soils out there, they might be spoils from excavation of the rest of the house that was just pushed out to the back. That happens all the time. Now somebody comes along either at the time of the original construction or later, and they're going to build their deck out there where all this fill material is now.
The fill.
The fill.
Can you, the trade term, what is that about?
Yeah, fill means that it's dirt that was taken from some other part of the site and it was just spread out in the backyard. That now is fill material, and if it was just pushed out there and spread without any compaction, then it's not going to do a great job of supporting anything.
Which is more than likely what happened especially on a slope.
Almost every time.
Right.
Yeah, and so we see a lot of decks that start out pretty well level, and after a few years, they're like that. They're going downhill because the part that's the farthest away from the house has settled on this poor soil. So, I mean, it's the same level of care you need to give to a deck as you do to the house.
To the house.
And people don't, which is why we get so many calls.
And that's why there's so many injuries and whatever related to decks, because they're, like you said, you call it a second-class citizen or something like that. They're not treated like the normal house.
Now the decks, I know when I first met you, I needed a foundation and drainage expert, and your name kept popping up. That also can play havoc on a deck, I would imagine, eroding the soil or having water dumped from the gutters right onto the...
That wreaks havoc on anything with a footing, and decks are Decks are no exception. So yeah, we get undermining. Sometimes we'll go out to a deck where the posts should be like that, and instead they're like that.
Sure.
Because the whole slope is going downhill. And maybe they cut a really nice bench and some firm good soil for the house, but again, the second-class citizen deck just got put out over the edge, and the soil is unstable out there, and down it goes. And that is a hugely expensive fix. We did one here not too long ago where we had to go in and put some drilled helical anchors and a great big concrete beam and then move those posts back.
Wow.
Very expensive.
Now, of course, we have tens of thousands of homes that are in the area where this show is broadcast here, and those homes are now anywhere from 15 to 85 years old.
We inspected a house today built in, we don't know exactly, but we think around 1870.
Wow, 1870.
Yep, still there.
Yeah, this is the one with all the decks. You talked about the cantilevered beam.
Yeah.
This had cantilevered floor joists sticking out that a deck guy came along and just chopped them off, right this far from the 2 or 3 inches from the house, nailed his ledger board on, and then built his deck on that, which everybody looked at that and said, well, wow, that's no good. And actually, in this case, it turned out that it wasn't too bad because the deck was so small. But had it been a big deck, it would have been a big problem.
Got it. Now, in terms of the foundation, by the way, I represented a buyer on a house that was on a hillside and the deck's going out, and it was now 30 years old. And the widow that owned the house mentioned her husband was an engineer, and he did his homework, and they had all the structural supports go 30 feet into the ground to the bedrock.
Wow.
And did everything. I mean,
That's
that
the way to
house
do
was
it.
level, flat after all those earthquakes. And
Yeah, well, there's a whole bunch too, what you're talking about. But when you drill down and get into the deeper strata of soil, your house moves much less differentially or settles differently.
okay.
And there's even geotechnical engineers we work with that have mapped the amount of movement the deeper they drill.
Now, I've had homeowners mention as a real estate broker where the decks operate in a different fashion depending on the season. So if the ground is full of water, it's operating one way.
Yeah,
in
that's
the
a good
summertime.
point, especially in the greater Bay Area.
Especially in the suburbs here. So can you talk to that issue about?
Yeah, I'll go ahead and then you can kick in too. The soil here is, they call it fat clay. Oftentimes it's also referred to as the Santa Clara Formation. And this material is typically lake bed type, old Pleistocene type lake bed material. Fine. It dries out in the summer and you have these large cracks that form in the ground. In the wintertime, it soaks that water up and then they fill up, and the soil actually expands in the winter and it contracts in the summer. And so a lot of times people say, hey, my door's pinched shut in the wintertime, but in the summertime it opens up.
Sure.
And any variation thereof. So you have some minor movement and things like that.
Yeah, well, that's it. It's all about the clay soils around here, and the water makes it shrink and swell, and it's going to lift your house as it does that. Unless your house is on deep piers, then it's not going to happen.
Now, I know decades ago, when they were building the homes, they had the fill of when they set a pillow for the house. A lot of times it would be structurally engineered differently than it was back in 1960 or 70, right? When you build a house on it now, in terms of drainage and putting the foundation and the post and pier, wouldn't the construction be different today than it would for a lot of the homes that were built in 1960?
Well, the answer is yes, because there's a lot of code changes since 1960. So building code changes every 3 years. But I can tell you, I've seen homes that were built in 1890 to 1920 that were built so well that they would be easily comparable to a quality of a home today.
Okay, that's good.
And actually, when we're talking about foundations, that science has not changed all that much over the years. What has changed a lot are the piers that you drill into the ground. That has come a long ways. But residential construction is basically concrete poured on top of soil that supports a house. And that's pretty much the same today as it's been for a good long time.
Long time.
Okay. Now you had designed, sketched out once about the different types of foundations that we use in the suburbs here and how they play out. But also, let's speak about drainage, because I know there's still a lot of roof systems where they have the downspout on each corner of the house, dumping gallons and gallons every winter. Now that has to affect.
It does. It can. It certainly can. And most current designs have that water going away from the foundation, and the point is you don't want it to get around the foundation, and particularly either under the slab if it's a slab on grade, or the crawl space, which is more common.
Okay.
Water in any area of the house, Tim alluded to that earlier, is not a good idea. Through the roof, through the side, through the crawl space, none of it's good. The foundation has a higher propensity to have issues of settlement and things of that nature if it's got saturation of the soil.
I think what they do with the downspout water, that's one thing that's gotten better over the years. In the old days, they didn't even have gutters or downspouts. It just went off the edge of the roof right next to the foundation and soaked and did what it was going to do. Sometimes it would go through and get into the crawl space. None of that is good. Nowadays, with code advances and building inspectors who actually care and watch, that downspout water is taken away from the footing, away from the house, much better.
I know as a realtor over the years, if I go into a home and then I walk downhill into the corner of a bedroom, I'll walk outside and there's a downspout on that corner.
Yeah,
Right.
like I say, it's a high correlation the older the house is, especially.
Now, in terms of, speaking of, in the real estate community, we have these home inspections, and the home inspector comes out and he says, I'd noticed there's some separation between the post and pier coming down from the house. Or are there little kitty wampus
Same thing we're talking about. The soil shrinks and swells. Over time, though, if it shrinks and swells and shrinks and swells, and each time it goes down and shrinks, let's say that it stays down a 1/16 of an inch or an 1/8 of an inch, over 8 to 20 years, it's gone down an inch. And so if it's gone down that much and the other bearing elements around it haven't gone down with it, then you're going to have the separation there. And that's pretty common again.
And again, that's a retrofit for a firm like you.
Oh yeah,
that
we
you
see that all the
operate.
time.
Okay.
Yeah. Settlement of the foundation, same thing. It'll be a corner of the house, like you say. It'll have drainage issues on that side or whatever, and that side will settle. If it settles so much that it starts to pull the house down and apart, that's when you need to hire somebody like us to come in there and fix it.
Okay. What about, you mentioned some of these older homes that are 1890 or 1905, and they're just solid as a rock. I've noticed homes in the teens or 1920s, how the foundation, how they created that foundation perimeter in terms of the cement structure. They didn't use rebar back then, right? And maybe it's just
rebar started coming in after the 1906 earthquake.
Okay.
Yeah.
So then I've noticed a lot of cracking. It seems, was the cement made on site with a wheelbarrow and a couple of
Let's make a
guys?
small correction. He and I are skins hackling. Cement is the glue inside of concrete.
Okay, right. Okay.
So it's actually a powder that's mixed with rocks and sand, and then that binds it.
Yeah.
So the concrete is what you're talking about.
So I've noticed through my travels that one foundation is cracked many times over, and the same home in a similar age is not.
Yeah, and it can be random too. You'll have one right next to another. One of them, I had one client who had during the 1989 earthquake, his house was the only one that imploded in his neighborhood. Everybody else was fine. And it found out that he had a really poor area of soil underneath that center section of his house, which they had to come back and they engineered and drilled a deep foundation to compensate for it.
All right, so if one is selling their home and they didn't have any inspections up front, the buyer comes with all these inspections, and we've noticed some cracks in your foundation. Is that the end of the world? Or
No, very common. And not too tough to fix either. And there's varying types that, some are more difficult to repair than others.
What you got to watch out though for, Pat, is when you've got a cracked foundation, usually that means that there's been some settlement. Concrete doesn't just crack, it has to move in order to crack. If it doesn't move, it's not going to crack. So when you see a crack, that means that concrete has moved in some direction or another. And the movement can be because the soil under it settled. It can be because it got shaken violently during an earthquake. moved it that way, caused a crack. So when you see a crack, you have to know why is the crack there. And as Mark said, we can fix cracks. That's not a problem. What we really have to be careful of, though, is to fix the underlying problem. Is it a settlement issue? Okay.
Right.
Now that's the problem.
Yeah.
Okay, I've been with you on an older house built in the 20s, and there was a retrofit after the earthquake. And the clamps, they shot in the epoxy into the cracks of the concrete, and then they had the clamps going around the perimeter in the crawl space that were from the foundation wall to the mud sill. And you had indicated, well, this is doing almost nothing. The house can still go off its setting, right?
That's why you have a professional engineer and somebody who knows what they're doing look at it.
Right. What we look at when we look at any kind of structural issue at all is we look at what's called load path. An earthquake really is collected in the roof, and it goes through the walls, into the floor diaphragm, through the mud sill, in through the anchor bolts, to the footing, into the dirt. There's a lot of links in that chain.
Is that because it's weaving in the wind, so almost that fashion?
Well, that's what an earthquake does. It moves your house side to side mostly, just like a really strong wind. So that your house doesn't rack all the way over and fall over, it's the walls that keep it up. But the walls are only as good as their connection to the bottom, to the foundation. And just that one connection has about 3 or 4 different elements to it. And so you can put those plates that you were talking about, and that's one of those connections. But there's still 2 other ones up above it that you have to get the load from the wall through the floor diaphragm into that mud sill. If you don't do that, your big clamp is doing really nothing.
Okay. Now, notice in terms of the suburbs, we have the home inspector comes out, and he's always talking about, was the foundation bolted to the house? Can you speak to, we hear of that in all the...
Yeah, that's like, the first basic minimum requirement is that the foundation sill plate we're talking about, which the concrete foundation, you have your wood, this sill plate or a plate of pressure treated wood or redwood, and then the floor diaphragm, which Tim talked about, is sitting on that. And if the link that we're talking about, the bolted piece, it's the wood that's bolted to the foundation that the floor sits on. But if you don't take care of the floor like Tim's talking about, that's only one piece of the chain. That's why you want somebody who knows what they're doing to look at it. And it all boils down to money. If you go out there and you spend, let's say, I got the best price from this guy and he came out and bolted my sill plate down, but you have toenailed connections or very weak connections on the rest of your floor frame, it's virtually worthless. It's not the cheapest one, it's the most expensive one, because when you have any significant movement in the future, it's going to fail elsewhere.
Okay.
And in fact, if you look at the pictures of the houses that failed in the Loma Prieta,
That's what I was going to speak about.
you will find out that the footings and the mud sills stayed in place. The house got knocked off the mud sill. So even though the mud sill may not have been anchored very well with anchor bolts, it was good enough to keep it in place. It was the links above it.
Again, the mud sill is a piece of wood that goes directly on the cement perimeter of the foundation.
Right, on the concrete,
The
right.
concrete, excuse me. Yeah. Now, the other one that we say, I want to hit as much topic as we can on this. Oh, there's a crack in the foundation and rust coming out.
Yeah.
So you have a lot of that.
Now, this is a little bit different. Typically, cracks are vertical, right? And they can be at anchor bolts, which is going to weaken that connection a little bit. And they can be from shrinkage, too. When the concrete is placed, water's added to it. So you get water, cement, sand, rock. You mix it together, and then it dries out. And as it loses the water, it flashes off. Then it loses volume. And that is called a shrinkage crack. So they're typically a very small crack, nothing to get too excited about.
Okay.
And when we assess it, we kind of throw the ones that aren't too important over, and then we start getting into the ones you're talking about. Now, this one's much more different. When reinforcing steel is placed inside the concrete to give it properties that concrete doesn't typically have, like tensile or axial strength, the concrete can start corroding. When reinforcing steel can start to corrode. When that starts to corrode, it can expand 6 to 8 times in size.
Wow.
So what was once a half-inch piece of rebar now can be as much as an inch round, pushing against the concrete in tension.
Splitting it all apart.
Right. And the problem is it doesn't just go one short section and stop. It's like cancer. It goes all the way around.
Right.
And I've inspected homes and 5 years later come back where they didn't do the repairs we recommended, and a 6-foot crack was 25 feet.
Oh my gosh.
Yeah.
And typically the abatement of that, you cut into that, snip it out, and put a new piece of rebar in, and
Yeah,
the concrete
we've got one we've worked out that's fairly inexpensive, although nothing is that cheap on this type of fix. The old method was to cut the whole section of concrete out and replace it, but there's new types of concrete polymer products, and there's new types of good epoxies that make this a cheaper fix, but it's similar to that.
Last one, closing out. You had inspected a house. They spent almost $10,000 to do a retrofit to keep this house on its foundation, and it was almost all worthless. This was after the big earthquake.
Oh, I'm talking, Pat, not just one. That was just one today.
Oh, that was just one today.
We're talking
So make
hundreds
sure
of
you
them.
check the Better Business Bureau. Check the
California Contractor State License Board. Get referrals from qualified professionals like realtors and other builders that are, competitors.
Make sure they're insured and bonded.
Insured and bonded.
And get a
That's right.
permit.
And a permit
get a
and,
permit.
and a good engineer.
Absolutely.
Okay. Garrison Brothers, thanks for coming out.
You
Thank
bet.
you for
Glad to
having
be
us.
here.
Thank you for watching Kapowich on Real Estate. This is a program dedicated to consumer protection within the residential real estate arena. We will see you next week, same time, same channel. Thanks for watching.